I am not 100% sure on which science lesson we got to. So I'm just going to start with lesson 22. I think we've already covered that, but in case we haven't, I'm just going to quickly go over it. So you have your periodic table of elements. So in our periodic table, we put a wavy line under our liquids. Your liquids are elements that if I poured them out or had them in this classroom at room temperature, they would already be in a liquid form. And those liquids were mercury and bromine, which mercury is, should be able to find mercury on your periodic table, number 80, and then bromine is 35. So those are the only two liquids in our periodic table. Then for our gases, we put a cloud around the element names of all of our gases. We had several that were gases, so I'm going to just call those out. Boron, number 5, sodium, number 11, magnesium, number 12, phosphorus, number 15, sulfur, 16, chlorine, 17, potassium, 19, manganese, 25, iron, 26, copper, 29, zinc, 30, and oh, I'm sorry, I'm reading. All right, let me go back. So our clouds, our gases, I was reading the wrong list. So these are our gases. Let's start back over. Our gases, we drew a cloud around those. That was helium, number 2, nitrogen, number 7, oxygen, 8, fluoride, 9, neon, 10, chlorine, 17, argon, 18, krypton, 36, xenon, 54, and radon, 86. And then finally we put smiley faces next to our mineral nutrients. So your mineral nutrients, those were the list I was doing in the wrong place. Your mineral nutrients are boron, 5, sodium, 11, magnesium, 12, phosphorus, 15, sulfur, 16, chlorine, 17, potassium, 19, manganese, 25, iron, 26, copper, 29, zinc, 30, molybdenum, and I may be saying that wrong, 42, and iodine, 53. Those are your mineral nutrients that should have smiley faces. So that will leave you with doing lesson 22 if you have not already finished that. And then we had that computer activity that I know that you've already done where you looked to practice using that periodic table. All right? Moving on, lesson 23 is where you took your food labels and you went through those food labels trying to find all of those mineral nutrients that we just went over that have smiley faces. And I know y'all have completed lesson 23 on your food elements. So that gets us ready for lesson 25. And I do not think I have gone over lesson 25 with you. So I'm going to look at the following elements. We have hydrogen. So go ahead and see if you can find hydrogen on your periodic table. We have helium. See if you can find helium on your periodic table. Oxygen. Find oxygen. Carbon. Neon. See if you can't locate these elements. Iron and nitrogen. So these elements, some of these are in the things that we eat. We find these 7 elements in the things that we drink. We also find these 7 elements in everything in our universe. If I were to take, say, this pen, for example, and break it down into what this pen is made out of, I would not be surprised to find some of these 7 elements in there. These are the 7 most common elements in the universe. Hydrogen, helium, oxygen, carbon, neon, iron, and nitrogen. So what I want you to do is take out your periodic table in your chemistry booklet. That's page 4 and 5. And let's find these 7 elements, and I want you to highlight them. Then at the top of your periodic table, where you have your key, I want you to put in the key a little highlighted box, and I'm fixing to show you mine. And right on that highlighted section, I want you to write 7 most common. So if you look here at my chart, I've done this. I have a highlighted section here where I've got 7 most common written. These are our 7 most common elements. And then I've located these 7 and highlighted them. So number 1, hydrogen is highlighted. Number 2, helium is highlighted. 6, carbon. 7, nitrogen. 8, oxygen. 10, neon. And 26, iron. So let me bring this closer to you so you can see. So you need your highlighted section in your key where you write 7 most common, and then you need those 7 elements we just talked about. You need those to be highlighted in your book on your periodic table of elements. Okay? Let me see where my chart has touched my board. Let's get rid of all those marks. Oh, there's going to be a bunch of them, isn't there? Well, we may just have to ignore them. It's going to take too long to get rid of them that way. All right, so let's keep going. Now, let's take an example of water. So, do you see water in your periodic table? No, water does not exist as an element, but water is made up of a combination of elements. Water, if I were to break apart a drop of water, I would find the 2 elements, hydrogen and oxygen, in my water. When I make water, it's going to actually look like this. Water is going to be made out of hydrogen and oxygen. This is the chemical formula for water, which is H2O. So let's look on page 6 and let's read about water and what our booklet says. Excuse me, first paragraph. A compound is a combination of elements fastened or joined together. Most of the things we observe every day are compounds. Carbon forms more compounds than any other element. Our bodies contain compounds made mostly from the elements oxygen, carbon, hydrogen, and nitrogen. Water is a compound made up of the elements hydrogen and oxygen. Look at that first sentence I just read to you on page 6. First paragraph, first sentence. This is your definition of the word compound. I want you to highlight the word compound in that first sentence. Now, what was the element that it said that I find in more compounds than any other? Carbon. Which elements did it say I find in the body? I find oxygen, carbon, hydrogen, and nitrogen inside my body. And what are the elements I find in water? Hydrogen and oxygen. Are hydrogen and oxygen, look at those on your periodic table. Are those solids, liquids, or gases? Hydrogen on our periodic table is a gas, isn't it? We put a cloud around it. Oxygen on our periodic table of elements is also a gas. We put another cloud around it. But look what happens when I put these 2 gases together and form water. Water is actually a liquid. So we're actually making something brand new. We're turning 2 gases into a liquid. When elements combine to make a compound, that compound usually is going to look very different from the elements that made it. Chemists write chemical formulas, and that's what this is. This is a chemical formula to show that elements that combine to make a compound. When we write chemical formulas, we use the symbols, those letters, those chemical symbols that you found on your periodic table. So it should make sense. Chemical formulas are made from chemical symbols. So that kind of goes together. So look at paragraph number 2. Follow along with me. Chemists use chemical symbols to show that elements that make up a compound. These symbols are called chemical formulas. The chemical formula for water is H2O. What is the chemical formula for water? H2O. In our next science lesson, we're going to learn about that small 2. And I'm going to go ahead and tell you that's called a subscript. And that's going to tell you how many of those elements you're going to need. But for today, we're just going to look at the elements that create these compounds. So at the bottom of your page, in your book, I believe you have a chart where you're going to be telling me what elements are in some symbols. So let me move up here. Let's look at what you have, and you fill them in as we go over them. So all compounds have chemical formulas just like water. Let's look at some others. Look at the chart on the bottom of page 6. So you have the chemical formula Na, capital N, lowercase a, capital C, lowercase l. So that's NaCl. Remember, a lowercase letter is stuck to a capital letter. They go together. Now let's go and turn back to our periodic table of elements. And let's locate these chemical symbols. So let's look for Na. Where do we see Na? Right here. Na is for the element sodium. So we're going to write in our chart over here, there's bullets. Those are the dots. We're going to write sodium for Na. And now let's find Cl. Where can I find Cl? Let's look for Cl. Cl. Right here. It's got a cloud and a smiley face. Cl is for the element chlorine. So next to the next bullet, we're going to write chlorine. We know that sodium, chlorine, if I put sodium and chlorine together, I'm going to create table salt. That's what table salt that we salt our food with is made of. Okay, I'm going to do one more with you, and then I'll let you finish your chart on your own. So let's look at ammonia. So ammonia has a capital N and a capital H, doesn't it? I believe there's a number in there, but we're not going to talk about the numbers today. So look at your periodic table and see if you can find what an N stands for. N is for nitrogen. Good job. And H, now some people want to put helium. That's not He. It's just capital H is hydrogen. So I'm going to let you finish your chart. Locate those chemical symbols that are in the chemical formulas to figure out what elements we see in carbon dioxide, propane, table sugar, and baking soda. When you complete that, you're ready to complete your lesson 24 sheet, which is titled Compounds. And so it's going to look like this. Use your book and your periodic table of elements to complete your compound sheet. All right, let's move on to lesson 25, and this should get you caught up. All right, I believe you got 3 papers that go with lesson 25. This is going back over our formulas, but now we're going to talk about the numbers that go with them. Today we're going to learn about the small particles that make up elements and compounds. We call these small particles atoms. Atoms, let's look at that word. A-T-O-M-S. Atoms are too tiny for us to see with our eye. We have to use a special microscope in order to see them because they're so small. Each little particle of an element is called an atom. So if I were to take the element gold and I were to cut gold until it is so small that if I cut it any more, it's no longer gold, I would be looking at an atom of gold. So it's the smallest particle of an element you can have. So an atom of oxygen, we would pretend that this is one oxygen atom, okay? So I put a capital O inside my atom to stand for oxygen. If I put 2 atoms together, I create a molecule. Now it's a molecule because I'm using the same elements. Same elements. They're both oxygen that I put together. This is what you breathe. This is a molecule made out of 2 atoms of oxygen. So each one of these is an atom, but together they are a molecule. So you have a box in your booklet on page 7 where it's going to ask you for you to draw a molecule of oxygen. That's what it's going to look like. Then it's going to ask you, so the chemical formula for this oxygen molecule is O2. That little number next to the symbol tells you how many oxygen atoms you need. So since it's O2, that number 2 tells me I need 2 oxygen atoms, which is why I drew 2 capital O atoms. You have another box for hydrogen. 1 atom of hydrogen would look like this. If I wanted to make a molecule of hydrogen, remember molecule means I have to use the same elements. So a molecule of hydrogen would need at least 2 hydrogen atoms. So this is 1 molecule of hydrogen. The chemical formula for this would be capital H, because that's how we make hydrogen, with the little subscript 2. H2 tells us we have 2 hydrogen atoms. So you have a box on page 7 for you to draw a molecule of oxygen, O2, and a molecule of hydrogen, H2. The little subscript 2 tells you how many you're drawing. Now, the chemical formula is what we look at to figure out what our picture is. And that little subscript 2 tells you how many atoms you need. Look at page 7. The title says Atoms and Molecules of Elements at the top. Let's read that paragraph. Elements are made up of small particles called atoms. When 2 or more atoms of the same element, same is a clue word there, fastened together, they form a molecule of that element. So you should have drawn your oxygen molecule, O2, with your 2 oxygen atoms, and you should have drawn your hydrogen molecule, H2, with your 2 hydrogen atoms. Look in the middle of the page. So now we're moving on to from molecules to compounds. Compounds are different. Atoms and molecules of compounds. So now we're looking at a compound. Remember, a molecule is the same elements put together. Now we're moving on to compounds. Look what it says. When atoms from different molecules or different elements fastened together, they form a molecule or a compound. So like a compound sentence in a language class is 2 different sentences put together. A compound word, when you're learning how to spell words, compound words are 2 words put together, 2 different words put together, like seesaw put together. So compounds in science are 2 different elements, 2 or more, we can have more, that are put or fastened together. So you have a sheet that is an activity sheet 25. So let me pull that out so you can see what that looks like. It says Lesson Activity 25. It looks like this, where we have some compounds for us to go over. So I'm going to put up my chart that looks exactly like your activity sheet. Give me 1 second. A piece of tape. Okay, I'm going to put up my chart. You have a sheet that's identical to this chart. Find that sheet. Okay, and we're going to work through this using our periodic table of elements. So these are compounds. Let me slide my camera a little closer. All right, starting up here. in vinegar. Now, vinegar is what we use to make pickles. People also use it as a cleaning tool to help clean their house. So in vinegar's formula is C2H4O2. That means vinegar is made out of carbon, from this capital C, hydrogen, the capital H, and oxygen, the capital O. The subscript numbers tell us how many of those atoms are in our compound. So carbon, because there's a little 2 behind it, tells me I need 2 carbon atoms. Hydrogen has a subscript 4 behind it, so I would need 4 hydrogen atoms. And oxygen has a 2 behind it, so I need 2 oxygen atoms. Nail polish remover. The reason nail polish takes off your nail polish remover removes the polish that you have on your fingernails is because it's a chemical in there that tears apart your fingernail polish to make it work. So the formula for that chemical is C3H6O. Notice there's not a number behind the O. We'll talk about that in just a minute. So carbon is a capital C, and the subscript 3 tells me I have 3 carbon atoms. Hydrogen is a capital H, and it has the subscript 6, so I need 6 hydrogen atoms. Now the O for oxygen does not have a subscript number behind it, but they have an O. So if there is not a number, then you need only 1 of those atoms. So if they do not put a subscript number behind it, you need 1. All right, I'm going to do vitamin C, and then I'll let you do the last one on your own. Vitamin C is C6H8O6. So what does that mean? That means I need 6 carbon. The capital C is for carbon. Capital H is hydrogen, and there's an 8 subscript, so I need 8. And oxygen needs 6. I'll let you do the fire ant bite on your own. Now down at the bottom, we have to find the element name and our subscript numbers. Remember, if there's not a number, you need 1. So I'm going to do only ammonia with you and let you do bleach and caffeine on your own using your periodic table. So ammonia's formula is capital N, capital H, 3. So capital N on my periodic table is for nitrogen. So I know I have to have nitrogen in ammonia. You should spell your elements correctly using your periodic table. Since there's not a number behind my N, I know that means I only need 1 nitrogen. If it was 0, the N would not be there. But since I see an N, I know it's 1 nitrogen. Capital H on my periodic table stands for hydrogen. Oops. Since there's a subscript 3 behind the capital H, I know I need 3 hydrogen atoms. So I want you to finish to your activity 25 sheet and have that ready to turn in to me. Okay? Put where my poster, put lots of marks on there for me. All right, the next thing that you got for lesson 25 to do was a computer activity sheet that looks like this. And I'm going to back my screen up. Okay, this was the next thing. So I'm going to have to draw some of these compound molecules up here on the board for us to use to help us with our computer sheet. So give me just a few minutes to get these drawn. So we have carbon dioxide was your first one, correct? And carbon dioxide is going to have a picture. So on your sheet, it says which atoms are shown in red, which atoms are shown in gray, draw and color the picture. So I'm going to be putting the picture up here. So this is, oops, let's do black first. This is your carbon dioxide compound. All right, and this is what it looks like. Those lines just teach us that they are combined together. Now, we just learned about carbon dioxide in our lesson 25 in our chemistry booklet, and we learned the formula of carbon dioxide looks like this, CO2. Then we learned what the little number means. It tells you how many atoms of that element you have. So what I want you to do is see if you can't figure out which element is red and which element, let me put my color, is gray. So you're going to draw this compound molecule of carbon dioxide, and then you're going to tell me which of these elements in the formula are red and which of those elements are gray. Okay, number 2 is for your water molecule. So I'm going to draw water one more time and use your colors. Water looks like this. And the colors we use are going to look like this. Now, if you got your colors correct on number 1, then one of those colors you'll use to help you with number 2. Remember, your formula for water was H2O. So tell me which of those what element is white and what element is red. The reds should match. So there's an element that you find in both carbon dioxide and water, and both of those match that red color. Number 3. Okay, it's going to look like this. And I'm going to use this color. Now, you already know these 2 colors, so I'm not going to put a chemical formula for this one. You already know your color gray, and you should already know the color white from your carbon dioxide and water. So I don't need a chemical formula here. You should be able to figure out what your gray and white is. So number 4. Number 4 is hydrochloric acid. This is on the back of your sheet. And it's going to look like this. Now, you've already learned what white is, but I'm now throwing in a new color. So I am going to put your chemical formula here for hydrochloric acid. And that will tell you what your green color is. So once you know what white is, you can figure out what your green is. And number 5, put it right down here so I don't have to go to a new page. This is for nitric acid. And it's going to be a big one, so it's going to look like this. And you're going to already know all of these colors except for one. I'm going to throw in one new color that we haven't seen yet. So you will need your formula. Okay, that's what nitric acid looks like. And so your formula for nitric acid is going to be this. So that should help you figure out what that missing color is, okay? Now, once you figure out all your colors on number 6, you're going to tell me which element was white, which element was green, which element was gray, which element was blue, and which element was red. Then I want you to pick any molecule that's in your book, in your chemistry book, on... Oh, sorry, I have it in my hand. In your chemistry book, on your chart that we did where you listed all your elements, Where did I put my chart? I already put it up, didn't I? Pick any one of these that you want to do that we haven't already done. So you could do vinegar. You could draw that. You could do nail polish, the chemical nail polish. You could do vitamin C. You could do your red ant bite. Anything that we have the colors for, you can draw. Tell me which one you're drawing and what your elements are and how many of each you have. And that will finish that sheet. Okay? So the only thing left to do is your lesson review 25. So that looks like this. You're also going to need those colors because there's a section for you to color to show those elements inside your compound. Use your book and the things we read about up here to help you on the difference between atom, molecule, elements, and compounds. Then you're coloring down here, and then you have 2 review questions. And that will finish up lesson 25. And that should get all of your science sheets on lesson 25 completely finished and ready to turn in. Okay? Now, I cannot remember if I sent home a lesson 26, but that's plenty for you to work on for the rest of this week. And so I will pick up on lesson 26 next week and send another copy home in case you didn't get that one. All right. If y'all have questions, let me know. That completes your science for this week.